So, in this we will study about the core elements of Terraform, right. So, the first one is Terraform command line interface, right, CLI. Okay, for all the tools, if you talk about Docker, if you talk about Kubernetes, if you talk about Git, for everything there is command line interface through which we give some commands and we try to play with it, right. Terraform helps you automate the creation and management of infrastructure. So, I have to definitely write some script and play with some commands. So, we need command line interface for that. This is one of the core elements of Terraform, right. And what are the commands? Some very popularly used Terraform commands. First one is init, means prepares your directory to run other Terraform commands. You have to initialize the environment or the directory. Then we have validate, means checks if the configuration is valid. Once you write some script, once you write the HCL, using HCL language, when you write the script to create an environment, to set up a configuration or do some changes in the environment, right, we have to use Terraform validate. Again, you see, like Docker, every time we have to use this Terraform, Tarraform, init is my command, or I have to give Terraform validate. Like this we have to give command always, right. So, once we give the validate command, it will check whether the configuration what we have given is valid or not, is it properly described or not. Okay. Next, plan shows what changes will be made to your infrastructure. It will show us what are the changes will be made. This is important. Most of the people in Terraform, again, most frequently used command is plan. Why? When I am when I am running one declarative script, right. So, what changes are going to happen, it will show to me. That will give me an overview about what we are trying to do, right. So, this is about the plan command. Then we have apply, execute the changes to create or modify your infrastructure. So, apply command will actually make the changes. It will include that changes in the environment. Suppose we are telling to create an infrastructure, create an environment, it will do that. Or you are telling change the class path variable, it will do that. So, that actual application will happen only after the apply. Then we have something called as destroy. So, it will delete the infrastructure that was previously created. So, it is all simple commands we have in Terraform, right. So, the game is actually in writing the HCL commands. How do we write that script is what we have to see. Okay. So, Terraform has beautiful environment where we can easily do that, right. Then the next one is Terraform language. Okay. So, using this language only we will be writing the script, or the infrastructure can be written as a code. That is possible with this Terraform language. Terraform is a name of a tool, okay, created by HashiCorp Corporation, right. So, Terraform uses a language HCL. See, HashiCorp configuration language HCL, okay, to define the infrastructure. Whatever infrastructure setting we want, configuration settings we want, that can be defined using this language. Again, it's no different from other programming languages. It's not too complex to understand. It's something like JSON or something like other programming statements what we have. But since it is their product, they have given one name. They wanted to have their own name for that particular language. So, they told it is HCL language. Okay. HCL is designed to be both easy to read by humans and understandable by machines, making it a great fit for DevOps tools. Very simple language. If you see the code here, it's very easily understandable. Resource is my AWS VPC, and it is a default VPC, and the CIDR block and IP address I have given here, and the tags, the name I have given to the tag is example VPC. Okay, we understand this. Infrastructure elements managed by Terraform are called as resources. any infrastructure. See, either you are setting up a database, setting up a virtual machine, doing some configuration settings, or setting up some firewall, everything will be called as a resource. Okay, this can include virtual machines, S3 buckets, VPCs, databases. This is what I was talking about. Your virtual machine is a resource, S3 bucket is a resource, VPC is a resource, everything is a resource. Okay, each resource is defined in a block. Okay, if you see the example for creating AWS VPC, if I want to create a virtual private cloud in AWS, I want to have a VPC, virtual private cloud if I want to create. See, I have to give something like this. The resource is AWS VPC and the tag is default VPC. The address block, what I am giving is this IP address, and that name what you give to that is example VPC, is the name of that particular virtual private cloud in AWS. See, HCL language looks something like this. So it will run and create that for you. Okay. Next, Terraform provider, right? So Terraform provider defines the resource types and data sources which Terraform can manage that platform, right? So it defines the resource types, what are the different types of resources we have. Okay, providers allow users to provision, configure and manage cloud services, databases, networks and more from a single workflow. Okay, so the third core element is Terraform provider. Basically, the job of provider is to define the resource types. Here you see, we gave the resource is AWS VPC. We are defining a resource here, right? So that can be done by the Terraform provider. So what all key important points or key important aspects which provider does is it acts as a bridge between Terraform and infrastructure platforms. It acts as a bridge between Terraform and infrastructure platforms, because this is a software and I have to do that setup in some platform. So in between I will be using Terraform provider. Again, Terraform provider will act as a bridge or a communication mechanism between both. Terraform provider defines the resources and data sources available for the management. Okay, it supports cloud providers, data centers, network devices and databases. So Terraform provider has lot of resources. Provider is the one who is actually helping us with those resources, and obviously it enables consistent provisioning across multiple environments, right? So this is also one of the important element in the Terraform. Then we have some modules in Terraforms. The fourth important element is Terraform module. So the next component is the Terraform modules, and we have set of modules. A Terraform module is a container for a set of related resources that perform a specific task. So we try to group the elements which perform a specific task, enabling organized and reusable infrastructure code. So the first one is module block, defined using the module block in Terraform configuration, which includes the following arguments: source, name and version. Okay, so specifies the location of the module, which can be a local path or a URL. Next, name means provide a name to the reference the module within the configuration, and version, we have to tell the version of the module which we are going to use. Okay, so what are these things? It's a container. Each module is a container for a set of related resources. All the resources which are linked to each other, we are trying to group them and performing all those resources which perform a similar task, we are trying to group them into, and we call that group as a module, right? Then resources and variables. The next module is resources and variables. Okay, what is this? Within a module block, users can define the resources that make up the module. along with the input and output variables. So, within a module we can know what we can say, define the resources. Okay. Input variables allow values to be passed into the module when it is called, and output variables allow the module to return values to the calling configuration. So, we can when the input is what input has to go, that is given through input variables, and what output will come, that is captured in the output variables, right. That is about resources and variables. And the third one is nesting. Modules can be nested, enabling creation of complex infrastructure architectures. Okay. So, this is about the modules, the fourth core element, Terraform modules. Then provisioners. There is if I just go back to the diagram of architecture, see here we have providers, right. See, we have registry here, all these are elements, see, right. So, we have this this actually we have to write this TF file. Once we write that, only then we can play with the files. So, the main game is using HCL to write this configuration file, right. So, in that same pipeline we have one more core element called as Terraform provisioners. So, kind of supporting tools. So, what is the use of these provisioners? Terraform provisioners are useful for tasks like copying files or installing software on virtual machines. Okay. However, provisioners should be used sparingly. We should use them a little, because it may introduce complexity, right. So, Terraform provisioners are useful for tasks like copying files or installing software on the VMs. So, what all can we do with the provisioners? Run commands or scripts after resource provisioning, commonly used for file transfer and software setup, can increase complexity and require elevated permissions. One drawback here, if you use too much of provisioner, then it will be a problem. Recommended only when native Terraform resources cannot achieve the task. Okay. So, kind of alternative for Terraform resources, right. We can use Terraform provisioners. Next, Terraform state, the most important concept. We have been talking about this. Declarative approach, imperative approach differ in terms of state, right. So, the desired state what we are expecting, okay, that is achieved using declarative approach, right. And if whenever you are giving some interview or you are somebody is asking you questions on the infrastructure as code, they ask you primarily, they ask you about Terraform, and in that they ask about desired state, or basically they ask about different states. What is desired state in Terraform or in IaC, right. Terraform state files allow Terraform to compare the current infrastructure with the desired state and apply the necessary changes. This is what the idempotency. When I have requested, I have written some script, I said I need some infrastructure, okay, then this Terraform state files, they will allow that Terraform to compare, check what is there already in the existing, check this, what is there inside it, and then you execute this script and apply only the necessary changes, right. While the state can be stored locally, remote storage is recommended for the team environments. So, we are storing the state information. So, existing state information is always recorded in some file. Whenever I am creating a new script and trying to execute in my machine, I will be referring to this file, understanding the existing status, and then only I will react on top of it, right. So, that is about the Terraform state. Okay. While the state can be stored locally, we refer them to store in remote. So, tracks real world resources and their configurations. Before I do that, I always track the resources. I know what is there inside the system which I am trying to set up. enables accurate planning by detecting infrastructure changes. Any change you are making through a script, that will be recorded again in the state information. I will just go back to the diagram again to show you what is that. See, I am storing one state file. Along with the config file, I am storing one state file in the Terraform cloud. Here also, see, Terraform state file. Before I apply this config file on the machine, I will also track this state file, right? So, yes, okay. So, it will take care of it will track by doing that. Can be stored locally, but is safer when managed remotely. And remote state improves collaboration, consistency and state locking. If you store it remotely, it is easy for collaboration instead of storing it locally, right? So, we have two concepts here, local state and remote state. What is this local state and remote state? This is a very important concept in Terraform. They ask you a lot about a desired state. What is state information? What do you mean by desired state? What is local state? Or basically, what is a Terraform state? State means the status, the current condition of that particular machine, right? So, the local state, by default Terraform stores state file locally on the machine where it is executed. Once I execute a script, I will generate a state file and store it. This approach is simple and effective for individual use or small projects. But when others want to see, when I am working on a single machine, I am working, if I am storing that locally, okay, but somebody else is working, if there is no state file for the second person, he will think that there is no, that software is not installed, though it is already installed. So, it will create problems, collaboration problems will come with the local state approach. Simple to set up and no additional backend required, ideal for learning, experimental and small scale deployments, faster access since the state files are resides in the local machine. But again, there are so many drawbacks with this local state. Higher risk of accidental deletion, difficult to share across teams, no built-in lock-in and it will create no conflicts. So, locally we should not store that state file. What we can do? We can store it in the remote, store that in the cloud. So, remote state stores the Terraform state file in a shared backend such as AWS S3, that is storage account, or Azure storage, or Terraform cloud. Terraform also has a cloud. In any of them you can store the state file. It is considered a best practice for production environments because it enhances security, collaboration and reliability. Okay, putting in remote in cloud is the best option. Benefits of it, it enables team collaboration, supports state locking and improves security. All benefits we will get, you know, putting in cloud what benefit we have. So, very commonly used backends or storage repositories for storing this Terraform state file is AWS S3, Terraform cloud, Azure blob storage, Google cloud storage, all these are storage services in cloud platforms. S3 we have seen, simple storage service, S3 means simple storage service S3. Terraform cloud, Azure blob storage, it's one of the storage, we have to create a storage account in Azure and then we have to work with it. We can store the Terraform state file in that also, right? And finally, the module registry. The final core element of Terraform is the registry. So, what is this? Private module registry enables teams to manage, reuse and distribute infrastructure code internally instead of relying on public registries. When I am working in a project, if I have it if I maintain a registry, it is easy for us to reuse, distribute and interact among the teams. By configuring authentication, users can seamlessly reference those modules in the Terraform projects. So, basically I store all that in registry, we maintain all that infrastructure code, so that anybody else, like in Docker registry is there where we store the images. Same way in Terraform we can store the infrastructure code in this registry. It's a repository or a storage facility, right? Stores organization specific modules, requires authentication to use this, definitely allows modules to be referenced, okay, and improves governance, security and code reusability. So once somebody writes a script, maybe we can reuse it, because same kind of script can be used for other projects also, right? So these are the 7 important core components of Terraform. If we just go back and discuss Terraform CLI, command line interface, where I can give the commands. Then language, HCL, HashiCorp configuration language, HCL language, using which we will be writing the script. Then provider, who will be providing us, defining the resource actually. Then modules, we have some modules like module block, resources, variables and nesting. Provisioners, alternative for the Terraform resources. Then state, very important, where we maintain the current status of the machine. Local state and remote state, remote is much preferred, right? And finally, the Terraform private registry, module registry, where we store all the code, whatever we have created, right? So these are few important modules of Terraform.